the ratios and also the trig ratios, also the compound angles, which you refer to them as identities, and also the part of simplifying and reduction formulas, and also the part of proving it. So in these ones, there are a lot of information that we have to know here, but the trig ratios of sine, cos, tan doesn't change. It remains the same thing that we know from any grade we learned. So it's the same information as I was saying the other time, saying that the important thing is to understand that the diagram of trigonometry, or the word trigonometry, the trigono means what? The triangle, and then the metric, it means the measurement. So it means that we are measuring the triangle. So in most cases, we are talking about the triangles, and those triangles that we are talking about in this part, they are the right angle triangle. In most cases, the triangles are the right angle triangles. And we know that the triangle, it has the three angles inside it, and then one of those angle out of the triangle, right angle triangle, it is a 90-degree angle. And then the remaining two angles, they might be the same or not. But then when we add the two of them, they are complementary, meaning they give us 90. So when we will add angle theta here and the unknown here, when we add the two of them, they give us 90. Then when we add the three angles inside the triangle, we'll have 90 plus the angle 1 plus the angle 2. They have to give us 180. And 180, we say that is the sum of all the angles interior on a triangle, or all of the interior angles in a triangle. When we sum them, we have to get 180. So out of that, we say that a triangle is a right angle only when it has the 90-degree angle in it, one of it. So last time I taught you about how to figure out the x and the y on a triangle, and then I think, or I'll just revise it today, because in most cases the triangles are drawn but not drawn they're not drawn to, what's this? They're not drawn to the Cartesian plane. When we're talking about the Cartesian plane, we're talking about the set of x and y, of the set of x's. Now this is the positive y as we can see it, and then these are the positive x's as we can see it. Sorry. Then on this part there must be the negative y's on this part. Then on this other side there must be the negative x's. So on this one, these are what we must understand. When the triangle is drawn to this, it means for now, this line that is drawn here, which is line y is perpendicular to line x. So which means the line y is drawn somewhere apart from the origin. This is origin. Point origin is 0 and 0, like I said. But then here now, where the two lines are intersecting, it means the two lines are perpendicular. The x line here and the y line here, two of them are perpendicular. Then if they are perpendicular, they are making up a right angled triangle. So which means the triangle here is right angled. And the triangle, it's measured on the longest side that is opposite to the right angle on a triangle. We call it the hypotenuse, simplified by r representing the radius. Then how do we figure it? We say that I just draw, for my side, I just draw a line from the 90-degree angle facing a side. Then that side, the line is facing the side itself. This side automatically becomes our r, or it becomes our hypotenuse, or the longest side on a triangle. Then that is how we will figure it. So which means that on this other triangle, our hypotenuse is going to be this one, because now our 90-degree angle is this one. And then I will figure out the line in which that the arrow is pointing, then which is this line. Then the line is r, or radius, or hypotenuse, which is the longest side. Then the remaining part, it is to focus on the one angle that is labeled, or that we are looking for. Now here, according to this triangle, we are labeled angle 1, which is angle theta. And then I said that the important thing here, once we labeled one angle, we have to still consider that the angle in which that we are talking about here, we have to say that between the two perpendicular lines, which is this line and this line, the two perpendicular lines, let's check Which one? From the line from angle 90, and then that when on the same line there is an angle. It means for now that line, it becomes our adjacent. How did they choose adjacent here? That's how I'm trying to explain here, that from the 90 degree, which is at this point, from 90 degree, which is at this point, with the same line in which that the angle is on, the angle is here, which is theta here, the angle is here. Then this line itself, it becomes the adjacent. And adjacent, we simply know or refer it as a letter X. Then the remaining line, that is the third one, is opposite. Then remain angle, sorry, side Y. So which means that all the single trig ratio, as a given example here, sine angle theta is equals to Y over R. Y, which is opposite, and then Y, which is hypotenuse. Sorry, R, which is hypotenuse. Then cos angle theta is equal to adjacent over hypotenuse, which is X over R. Then we go to tan theta, which is tan angle, or tan theta is equals to the opposite, which is Y, divided by the adjacent, which is X. Then this is how we end up arriving in the end. This is the important thing, people. We have to understand and know and identify our triangles. In what way we know which side is X, which side is Y. We consider X and Y once we know the angle, that is the angle that the question or the examiner is looking or is talking about, so that we can now understand. We don't just choose any angle or any side on it. Now, going further here, we said that it deals with the length and the angles. The length, we're talking about the X, the Y, and the R. And then when you say that, it is given by the equation. This is now the theorem of Pythagoras, if you remember. The theorem of Pythagoras says that the R squared is equal to Y squared plus X squared, or X squared plus Y squared is equal to the R squared. And if you can check very well, this is the equation of a circle. And if you remember very well, the equation of a circle means that the circle is drawn to a scale on the set of axes. Now, the set of axes, either to a scale or not, but then the circle is drawn, and then this circle is passing through the origin. The circle is passing through the origin, and if the circle is passing through the origin, it means that it's easy to find one side if we are having the two on that triangle. Therefore, going further, they said the Pythagorean theorem can be used anytime if we have the right angle triangle. You see now, the key part with the keyword here is only we use the theorem of Pythagoras if we are having what is the right angle triangle. And then where the two sides, and we want the two sides, we have the two sides, and one of the angle is given, or the two sides using the theorem itself to find the third side. So we are either having X, or we are either having Y, or we are either having R. Any of the two from the three, they can help us figure out the third one. That's always the case. And remember, it only applies if the triangle is a right angle triangle. Not so, then please don't use the theorem of Pythagorean. Now, R is always the longest side, and it's always what? Positive. What do they mean it's always positive? Because it's the length, it's not the part of axis, it's the length. And then it's also what opposite to the 90 degree, like I showed you how it is, or how do we figure it. Like I said, in a triangle like this, that is a right angle triangle, and then we just know that from the angle 90 we draw an arrow pointing this side, and then the arrow going to this side it becomes our hypotenuse, which is our R. So this is now our R, the longest, and they say it's opposite to 90. This is our 90 on this triangle. This is our 90 degree. Now, trigonometric ratios, we're talking about the sine, we're talking about the cos, we're talking about the tan. These are the things that in which we consider and we talk about in most cases. And please, these things, they don't change. If sine is y over r, and if cos is y over, so this x over r, and if tan it's y over x, this remains the same. How do you then classify the x and the y and the r? You have to look at your triangle and identify the x and the r and the y on your triangle. Please don't forget to do that, because it's very, very, very important to understand. Are we clear on that one? Good people.
Yes, sir.
Okay. It means we move further. Clear means we move further. Okay, moving further on this one, we are now configuring the angles. We are now inputting the angles in a Cartesian plane, where remember when we're talking about the quadrants and also the stuff, now the angles, we are talking about them in here. We are not putting the angles in the Cartesian plane. This is Cartesian plane, the set of x's. It doesn't change. This remain x, then this remain y, this remain negative x, and then this remain negative y. They don't change this one. It's just that in most cases, they don't want to show you these things, but they are always there. Now they only show you in terms of the angles. Okay, if you can see, they are only showing us this thing in terms of the angles. So it means on this line, we are having angle 0, we're having 360, we're having angle 720. And then going to the perpendicular line on this one, on this line, we are having angle 90, or we are having angle 450. And then on this line, you are having angle 540 and also angle 180. This side while is also angle 270 and angle 630. Now, if you can see, we are having the letters here. The letters that are letter A represent all. A represent all. Represent all what? All the tan, all the cos, all the sine, all of the trig ratios. And then S represent what? S represent sine, and sine, remember, it's an angle, while T represent what? T represent the tan, while cos represent what? Cos, C represent the cos. Now on this cos and on this tan and also on this sine, these are the trig ratios in which that they are positive on those quadrants. Remember, I said that the quadrant is a circle that is divided into 4, and then each part or each section of the circle is referred to as a quadrant. Now in this part, we're having quadrant number 1, while on this part, we're having quadrant number 2, while on this section, we're having quadrant number 3, while on the last section, we're having quadrant number 4. So on this one, we are moving anti-clockwise. So from angle 0 here, we go to angle 90. From angle 90, we go to angle 180. From angle 180, we go to angle 270. Angle 270, we go to angle 360. Angle 360, we go to angle 450. Angle 450, we go to angle 540. Angle 540, we go to angle 630. From angle 630, we continue going to angle 720. So this is going to help you to reduce, to know where are these. So for example, if they say cos 720, so automatically cos 720 is in quadrant number 1, is in quadrant number 1. This is quadrant number 1. This is where the angle is going to be in this part. From this part, from this region to here, the angle will be in this way. Because here, this line is 0, is 360, and is 720, and it falls within the first quadrant. So if we are having, let's say, for example, cos 180, cos 180, it means this cos is going to come in this direction, and 180 is in between here. From 90 and 180, 180 is in here, and this side is quadrant number 2. So which means in cos 180 is going to give us a negative number, or it's going to give us less than 0. So this is what they mean, or this is just an example. So when we put cos 180 in a calculator, it's going to give us -1, and -1 is a part of an x which is on this side, and yes, automatically on the second quadrant it means cos is negative, because only letter given here is s for sine, which means the other side, cos and tan, they are negative in this quadrant. This is what they mean. Now let's hear the readings here. What do they say? Now it clearly determines the status of each trigonometric quadrant. Remember, the quadrants are the quarters of a circle when it's divided into 4, and then now we call it the Cartesian plane. Even if sometimes the circle is not drawn, it's just an imaginary line there, is not drawn, then it means it's a quadrant. Yes, we assume it is a quadrant. Now for the first time, we have the first quadrant and all the trig ratios are positive. It means cos, sine, tan are positive. And then the second one, which represent S, the second quadrant, it represent what? It represent that only sine is positive. So the second one, the S, like I said, the S for my side, it represent sine. So it means sine on them second quadrant is only positive. If you have tan on this quadrant, tan is gonna be negative. Then if we're gonna have sine this side, cos also, for example, cos is gonna be negative. Let's just say we're having cos 95. So cos 95 is the 95 angle is more than 90 and is less than 180. It's in between here. So which means when you punch this thing on a calculator, it will automatically gives you a negative number. And if it gives you a negative number, that's what they mean. Then going further, the third quadrant, and only the tangent that is, or the tan that is positive. That's what they mean, which means for cos and sine, they are negative numbers. When coming to this one, it means they will give you negative. Why are we saying they will give you negative or they are negative? Is because of this side on the third quadrant, x is negative and y is negative. And remember, our sine is the y over r. So which means we're going to have negative y over r. Remember, automatically, this is a negative number. And then if it was a tan, we're going to have x over r. And this, since this side x is negative, we're going to have negative x over r. And this is going to be negative number on a calculator. That is why I'm saying, or they're saying that they are negative in this format. Are we clear?
Yes, we are.
Okay, now let me introduce more of the angles here so that we can get to see more of these things. Because the important thing is to understand them. And so that when we apply them later, we now know where are they coming from. When we say some of the things that you might not understand, you will know where they are coming from. So now just introduce those single trig ratios in each and every quadrant and with their values, and then showing that these lines here, they represent a triangle. How do they represent a triangle? If I now draw the parallel line from the y-axis now to this, they make up a triangle, then it's a right angle triangle. If I had to draw to this one again, I will draw it in this way, it will make up a right angled triangle. This is what we are talking about, or this is a kind of an example that they will give you so that you can now know and understand in which quadrant is it, and then in which triangle are we talking about here. Good. Now, let's see further on the first quadrant, or quad number one. Quad number one, we are having sine, sine is positive, or having tan, tan is positive, we are having cos, cos is positive. What do they mean? It means the value of them, they are positive. How so? Because when we now figure out, or what is sine, cos, what is tan, what is sine, cos, we know that now sine is going to be equal to y over r. And a y over r, remember, or on the first quadrant, in the first quadrant, y is positive. On the first quadrant, y is positive, and then r is also positive. And then here, if we cos, we're going to have x divided by r. And x is also positive on the first quadrant. And then again, we're going to have tan, which is y divided by x. Both x and y are positive in this quadrant. So we cannot not understand or not know, because this is how we get them being positive accordingly. We get them being positive due to figure that in this manner, this side, the x value this side is positive. If you see, the x value this side is positive, and the y value this side is positive. So which means anything to do with x, to do with y, they are positive numbers. This is what they mean. We're talking about it in this way. And this is the x and y at this point that you're talking. This is a coordinate now. Now, in terms of angle, this section from here up to here, we are having theta, that is a small angle. So it means for this region, we are having 90 minus theta. It means for all the angles that are here, they are all minus, oh, sorry, they are all less than 90. So when, if theta is this small section, it means for the remaining big part, this one is what? Is 90 minus theta. So if it's 90 minus theta, it means that every section here, or the first quadrant, it's more like saying 90 minus theta. So you get to understand that. So we go to the next quadrant. The next quadrant is second quadrant. Second quadrant, we are having sine, we are having cos, we are having tan. Still the same. This side, y is positive, and then x is also this side, and then on this line x, this line is negative. So which means now, for the sake of sine, we're going to have y over r, which is still positive and still correct. We're going to have y over r, which is still positive. But then when going to x, actually are going to have negative, so we're going to cause, now we're going to have negative x divided by r. Why negative x? Because this side x is negative. Yes, and then going to tan, we're going to have y divided by negative x. Y is positive. Why is y positive? Y is positive because this section is also positive. And then why is x negative? X is negative because on this section, the second quadrant, x is negative on this line. This line y is negative. Now, if we are to make a coordinate somewhere here, and then let's say this coordinate here is x and y, then we're going to have something like, let's assume -2 as x value, and then we're going to have 5 as y. So which means, or you can see, because now when we do a coordinate, we'll have x value negative, but the y value positive. That is why on the tan, we'll have y value divided by the x value as negative. So that's how we're going to get tan negative this side. That's how we're going to get sine, cos negative on this side. Then we go to the third quadrant. Third quadrant is negative, sine is negative, y over r is negative, cos is negative, y over r. So sorry, negative x over r. This is on the tan. And then we go to, so on the cos. Then we go to the tan. The tan is positive number. Why is this positive number, or tan is positive on this section? It's positive because we are going to have negative y divided by negative x on this region or on this quadrant. Here for the y, we're going to have negative y divided by r. And then for x, we're going to have negative x divided by r also. And then for tan, we're going to have negative y divided by negative x in this one. How so? How so? It is so because in this region, y is negative in this part, and this is the part of y, and then it's negative. If I am to make a coordinate here, I will have that coordinate as negative x and also negative y. The coordinate is going to be negative x and also negative y in this part. Why is it negative? Because of them. Because of the point lies on the third quadrant, and the point lies where the x value on the side is negative and the y value is negative. So if I give an example for any number, let's just say take the same number as -2 on this side, and then we're going to have -5 and positive 5. So this is our coordinate that we just estimate what it is. So this is x and this is y. So we're going to have negative y, which is -5 divided by -2, which is negative x, and then we're going to get the value. And then we will say that the value is positive because we will have negative divided by negative, which gives us positive. That's how we get tan in this quadrant being positive. Then the last quadrant, which is quadrant number 4, or before we go to the next quadrant, on the third quadrant, we reduce it by 180 plus. While on the second quadrant, we are reducing, or we are to reduce it with what? With 180 minus and also 90 plus. Now the two graphs, sorry, the two angles here that we're talking about, the angles here, angle like what is this? Angle like 90 minus and 90 plus. The two angles, they are what we call the cofunction. Cofunction meaning what? They are changing the trig ratio. They are interchanging the trig ratio. So if in state of tan, you can change it into something. If it's in state of sine, you can change it into something. If it's in state of cos, you can change it to something. Meaning, or if we are having sine 90 plus, it will change into something. If we are having sine 90 minus, it will change into something. It won't lead you into sine. It won't lead you into sine anyhow. But we will get to that as an identities for coefficients. Then we will understand what is that and how do we get to everything. So now the last quadrant is quadrant number 4, where the cos part is positive. The rest of them, sine and cos, so sine and tan are negative. How so? Because of y this side is negative, and a sine is y over r, so we're gonna have negative y over r, and a tan is y over x, so we're gonna have negative y over x. That is why everything now is is negative. But for cos, the x value on this side is positive, and then we reduce it by saying 360 minus. So we don't reduce by 270 or anything. We only reduce by 90. We reduce by 180. We reduce by 360. Please be careful when we reduce in future. Do you have any questions?
No.
No question. No question.
Yes, no question.
All right. Which means we move. Let's move to the next part. Okay, the next part I want us to start with the identities. Now, on those one identities that we're talking about here, we will be talking about the simple identity of 1 and also the identity of the quotient. Quotient meaning what when we divide the other, we get something. For example, we start with tan. Tan A is an angle. It can be any letter like a theta, alpha, beta, x and y. So now they just I wanted to use A as alpha. So now it means your tan alpha or tan angle, wherever you see it, it's more like a sine angle divided by a cos angle. You can only do this if the angle is the same. So for example, if you are having tan A, you cannot say tan A is equals to sine A divided by, well, let's say sine A divided by cos B. You cannot do that. Why we cannot do that? Because now these two things are having two different angles. So we can only say they are if they are having one same angle or same common angle. English is too much now. So if the angles are not the same, we cannot conclude to saying that the identities are equal to tan. Like for example, if you in an expression you are having sine A divided by by cos B, or you are having sine 22 divided by cos 20, and then you want to say that many have said that when we say sine divided by cos is equals to tan. No, the angles are not the same. We are having 20 and 22, which are two different angles. But if it was sine 20 divided by cos 20, then we can say it's equals to tan 20 because the angle is the same and sine is dividing the cos. Only that. Then the next part, we go to the part of the identity number 1. Identity number 1 or identity 1, it says that the square of angle A plus the square of angle square of sine angle A and the square of cos angle cos angle A, when you add them, they give you 1, no matter what. So there are many ways in which you can write this 1 by any chance. So for example, if you are looking for sine squared angle, you can express sine squared angle from this. Or you can say, if you are looking to change sine squared angle, you can change it into this form. Or if you see this form anywhere, you can change it into this form. So far, you can still do the same thing. But the further thing is, let's not dwell much on the other one. Let's not dwell much on this one because it won't benefit us. It's just going to complicate us further because we will use identities when we mostly prove and simplify. So when we prove and simplify, we cannot leave this thing in complicated ways like this. This is a complicating part. That's why I'm saying let's leave it for now. So in this manner, if we are to look for cos squared angle, we will say 1 minus sine squared angle. If we are to look for sine squared angle, we will say 1 minus cos squared angle. It's more the same like if it's in this expression like this one, and then this equation, we are looking for cos. If we are looking for cos, then I am to take sine squared angle from this side to the other side. So when I take it to the other side, I have to multiply by negative. That is why I will end up having negative sine squared angle. That's the identity of 1. Do you have any question on that one? No question. Proceed. We move forward. Forward we go. The last part. Now, the last part is of the compound and also the compound and also the compound. Compound and the compound and the compound, these are the identities of the compound and how we can prove them. Remember, or in mathematics, sometimes when you are given a solved example, you think or you can do it on your own. So I won't let you go for free on this one. I'm going to give you a work, but not to prove these formulas. It's very rare to be given an examination that prove the formulas, but when it comes, make sure that you know of it. We are having cos angle A plus on angle B. So this A is alpha, this B is beta. So when we are saying if we cannot figure out to give us the answer, we now remember to express. When we plus the two of them, it's more like saying that now cos. Don't forget that cos. Two different angles. Now the signs are changing. How are the signs changing? If here it's plus, in between two cos, it's going to be positive. And then sin. The angles are different. So when we sing it together, we'll have cos plus sin. So cos A plus B is going to be cos A cos B. Sorry. It's not plus here. It's supposed to be negative. So if it's cos A minus, sorry, if it's cos A plus B, we are going to have cos A multiplied by cos B minus. So when we express this thing further, when we simplify it further, it leads us to minus. So we will end up having minus sine angle or sine A multiplied by sine B. So it's up to you how you write it in the form of angle, which one comes first. But the angle that comes first is angle A. So we go with this one as the simplified version of it. So the identity of this one, even in your formula sheet, is this one. They only give you this one. So you can only do this if you are to prove it. But how do you prove it? You don't prove it by just rewriting it as it is. Now, the proof of this thing, we have to figure it out in a manner that is not difficult to do it. Now, if we are to say that we are given cos angle A minus cos angle B, it means or now the sign in between here is going to change. It's not going to be minus, but it's going to be positive. So it means or we are to be careful. If cos is cos angle A minus cos angle B, if here it's negative, then here it's going to be the positive. Because here if it's positive, here it has to be the negative, and here is the negative. That is the compound. It's also there in your formula sheet. It helps you to express and simplify some of the trig ratios when you simplify the expression given, or also you prove, or you are to calculate, or you are to solve. You use identities to find or to simplify the other identities. The next one is of a sine. Sine is sine angle A plus angle B. So this one is the straightforward one. Just that now the first part we are saying sine multiplied by cos, the two different angles, plus, and then cos different angles multiplied by sine different angle. How we came into this one, we derived it using the, but again, the co-function angles, the one of 90 plus and the one of 90 minus. So you can see they have reduced this by saying it's 90 minus. So when you reduce when you reduce sine A plus sine B, we reduce it from cos 90 minus an angle. So it's gonna give us this one. Remember, our sine changes into cos, and then we will give it into that way. But we'll come to it in few slides coming from now. The next one is when we prove sine angle A minus sine angle B. So we go figure it out in the end. Then we will have sine A cos B minus. Minus is minus. There's no changing, or there's no changes in it. So it remains minus as it is. And then we figure out the answer as it is. So these things are helping us when we simplify. So don't think examiner will give you the formula sheet and also gives you this formula sheet already being explained, and then when you don't use them, you're thinking or you are doing it right. So no, it's all about changing what you know into what you are given, and then you continue working out. That's how we keep understanding in this part. These are we call compound angles. The compound angles. The compound angles. If you don't have any question in this regard, let's move. Any question? No question. Now, since we were doing the compound angle, the next part we are doing the double angles. Double angle meaning or now the angles they are 2. Let's say angle 1 multiplied by angle 2. Now they gives you 2. Now, for example, we are having a 2 angle, 3 angle. 3 angle is more like saying angle 2 plus angle 1. But it's not double, it's gonna be compound. Now we're having 2 angle. 2 angle can be sine 2 angle, it can be cos 2 angle. So wherever we see the two of them, we know that now we are having our identity, and identity is double angle. Double angle we choose. Now when coming to sine double angle, we choose only one. We are given only one. So we don't have to have more options when coming to this one. We choose only one. Please don't be left outside. We choose, and which is this one. So if we are given sine 2 angle in this manner, sine 2 angle, no need to express it in this further. The angle is further just substituted in this way. So you see now we are given single trig ratios now. We are given 2 multiplied by sine angle, cos angle. The angles are the same. Don't forget that. The angles are the same. This is there on your formula sheet. I don't want to talk more about it. Then the second one, when you're given cos 2 angle or cos double angle, we have 3 options to choose from. The first one we choose from this one, which is cos squared angle minus sine squared angle, and the angle must be the same. If they are in numbers, the numbers must be the same. If it's 22 and here you are going to have 22, and also here you're going to have 22, it means they are now the same. That's option number 1. Option number 2 is expressed and is also simplified in this one, which is 1 minus 2 sine squared angle, and angle has to be the same. So which means you can choose and remove any of your choice. And don't forget that sine squared angle is also an identity. You can check it from 1. We're going to have 1 minus cos squared angle inside the bracket. Then lastly, we are given the option of 2 multiplied by cos squared minus minus 1, cos squared angle minus 1. So here, the 3 of them, you are regarded to use any if we are proving or we are simplifying. If you see it and then you want to simplify it to a certain trig ratio, if you are talking about the causes in your explanation, you cannot choose this one. But if your expression is all about the causes, you can choose this one. You will get your answer in the simplest way. But if your expression is all about the sign meaning most of them, they are remaining being signed. When you change them, it means when you change the identity, you can opt for this one. But when you opt for this one, it's more gonna be easy for you to work on one single trig ratio all the way and then work it out. And that's how we figure out the angles. They must be the same. Please, that is the important part. The angles. If we are talking about theta, let's talk about theta. We can only convert and change if the angle is theta. But if the angle is not theta, we cannot. So for example, if you see something like this one in your statement of solving or simplifying, you see something like cos 2, or you see something like sine 2 multiplied by, let's say 2 multiplied by sine 40 multiplied by cos 30, and then you want to say, oh, Mr. said that if it's 2 multiplied by sine angle multiplied by cos angle, I can change it yaba 2 multiplied by yaba sine 2 multiplied by 40. No, it cannot be. Or 2 multiplied by 30, it cannot be. Why? Because the angle is not the same. Here this side you are having angle 30, on the other side we are having angle 40, which is completely wrong. It's not an identity. Identity is only when the angle we are using the same. Please bear with it and be careful when coming to solve it in that manner. Do we have any question from now? Okay, no question. Lack of knowledge, my people perish. No question. Remember, always if you don't have a question, I have a question for you. Now let's just find one simple example here that we can try to trick it together and apply all those skills that we just consumed now to see if we can figure out what is happening. Okay, we are having one example here. We are It's one of the question 5. Now, on one of the question 5, we are having an example in a form of that. They say that in a diagram, PR is perpendicular to TS. And then in obtuse triangle, okay? PTS is a triangle that is obtuse. Then again, PT is equals to root of 5, TR is equals to 2, PR is equals to 1, PS is equals to root 10, and RS is equals to 3. So in other words, you are given all the sides in this triangle. So the tricky part can give, they can ask you is to find the angles. Now, I'll give you the strategy in which you can try to break out here. Be careful and be careful with this one, because if we can't be careful, we won't understand these things. Let me just redraw this diagram as it is, so that we can now know and record it together. T2 root 5, P common, and then R1, then 3 S root 10. Okay,
Edwin,
this yes.
sorry, I can't see your camera.
Yes,
I can only see the screen.
I'm not yet writing on my camera. I'm still copying down the question from here. Okay, now let's go back to the diagram. Here, let's come here. Here on this one, we see very clear that the diagram is drawn, and then the diagram, if they said here is 90, they showed is a right angle. So the first of all, take out the triangles that are right angle triangle and draw them separate. That is my advice. The first triangle is triangle PTR. PTR, I will redraw it in this manner. PTR. I will put P here and T here and R here. And then TR is 2. And then a TP is root 5. And then PR is 1. So which means 1 is common on the both side of the triangle, because it's PR. PR gamlo the second triangle. And then I will put 3 here, I will put root 10 here, and then I will put 1 here. So which means I'm having 2 separate triangles that are right angled triangle. So which means on each of the triangle, I can work out what they want me to do. Now, for example, the first question there, or before we look at the question, let's look at triangle. Let's look at triangle PTR. Triangle PTR, we are given angle at R is equals to 90. Reason going, it is given. Now, if it is given, we are looking for angle at T. Angle at T, we don't know. We are looking for angle at P. Angle at P, we don't know. So we are given all the sides on this triangle. Now, the first thing is that, now my question is that when we look for angle at T, this is the angle at T that we will start looking for. Now, if we are looking for angle at T, it means now we have identified where the angle is positioned. Now, let's first identify which side is X, which side is R, because automatically the R of this is gonna be, when we draw the straight line or the arrow from the 90 degree, it's gonna point the radius, which is R, or which is root 5. And then let's figure out which side is X, which side is Y on these 2 remaining sides. Now, I said that on a perpendicular lines, let's draw a line from the perpendicular part where the angle is 90. Now, let's follow one of the 2 lines and go where the angle is, which is this one, which means now our our X is TR. So if our X is TR, it's obviously this side is X, this side is Y, while this side is R. So we are given in that way. So we can use any of the single trig ratio. Which trig ratio? We can use sine, we can use cos, we can use what? We can use tan. It will still give us the same thing. In which manner? Let me just choose cos. Cos, we are going to have cos angle T. Cos angle T, it has to be X over R. X, which is what? Which is 2. R, which is what? Which is root of 5. So which means in this manner, we are going to figure out what? We are going to figure out what's this? We are going to figure out the angle by saying on a calculator, we will press shift and then we will press cos, and then we will put down the numbers as they are, which is which is 2 divided by root of 5. And then when you punch on a calculator, we will have something like angle T is equals to cos into brackets minus 1 to root of divided by root of 5. Then it's going to give you something like angle T is equals to 26,57 degree. And this is the angle of this is the angle at T. So which means now our angle at T here is 26,57. So you see, what do we do? Now, the next thing, I want us to figure out angle P without using the law that says that the sum of all the interior angles in a triangle, they add up 180, and then without saying 90 minus 26,57 to give us this thing, which is 53,43, without giving us in this way. Let us use a trig ratio to find the angle at P. So which means me and you now at the angle at P. Let me wrap this original triangle. Now, which means that on the angle at P, we now have to figure out which part is X, which part is R. Why? Because R automatically is here. We are given. Now we have to rearrange our X and Y by saying that the line drawing from the 90 degree where the angle is, that line becomes X. So which means now our X is this part. Therefore, the remaining part is our Y. You see, we have to be careful with this thing because they interchange. Now, if we are to still use cos, we are going to use cos angle at P is equals to line PR, which is X, divided by line PT, which is R. And then, which is going to be 1 divided by root of 5. This is what we are going to have. Remember, Oring, now this thing is not the same as 2 divided by root 5. Don't confuse the two. Now is when the angle has changed and we are changing the positioning of X now. Drawing the line from the 90 degree, that line that has an angle, it's an X. This is the important part, please, because if we cannot get to understand this, we are failing to solve. Now, when we get to this and solve, we will get something like that, which is equals to cos shift 1 over root 5. Then the answer is as I have predicted, which is 63,43 degree. Without using what? Without using 90 minus to get this. Yes, it's a shortcut and it's easy to get it. But now let's apply the skill of understanding the concept of what we are doing here. So which means now the angle at P is going to be 63,43, while the angle at T is going to be 26,57. Now let's go to the other triangle, the triangle of PRS. Now, in a triangle of PRS, we still have to figure out what? We are to figure out the angle at P. Now, the angle at P, we start by labeling X, R, and Y. Line drawn from the perpendicular line going to certain angle, so certain side. That side becomes R. Hypotenuse, the longer side. And then let's find X. We can only find X and Y if we know the angle we are looking for. Now we know the angle at P. Then I draw the line from perpendicular the 90 going to the angle which is at P. Then that line is X. So which means our 1 is X. Obvious, this side is our Y. Then we will have something. It's not always the case to use cos. I can use sine now. Let's use what? Let's use sine. So when we use sine, we will have something like sine P is equals to Y, which is 3, divided by R, which is root 10. And when you punch on a calculator, we'll have angle P is equals to shift into minus 1, or arc sine is 3 over root 10. We can always use sine or shift or sine, tan, or cos. We are not always expected to use cos like I'm using. So be careful on that one. As long as you can identify your x, you can identify your y. So we'll have 3 divided by root of 10. So in my calculator, it's going to give me 70. Angle at P is equals to 71,57 degree. So without further ado of saying that now the angle here that is remaining, it's 18,43. Then we can just simply use the trig ratio to figure out the angle at S. We cannot say 90 minus 71,57 to give us this. No, we ignore that, even if it's a correct thing to do. What do? We must use a single trig ratio. And when we are now changing to look for this angle, it means also the x and the y changes, but the r remains the same. Since it's in this one, from 90, I draw the line going to the angle. Then that line becomes x. The remaining y becomes y. Then it means, or if I use sine again, I'll have sine angle at S is equals to y, which is 1 over root 10. So I will have shift S is equals to shift negative sine, okay, 1 over 10, 1 over root 10, which gives us S is equals to 18,43. Now we got the angle. This is the important thing that we are to understand, please. Do we have any question? Do we have any question?
No, not by me.
Okay. If you don't have any question, let me just simulate this one. Like on this part, the first question was saying, where is it? This one. Determine sine t, sine angle t. They didn't say determine angle t. They said determine sine angle t. So which means sine angle t, we must know where is it. Angle t is on the small triangle which was drawn as PRT. This is where the t is. This is where the t is. The angle t, they are looking for this one. So sine angle t, it means for now we must figure out x and y. Since this is an angle, line drawn from the 90 degree going to an angle, this is an x, then this is a y, then obvious the remaining part is r, or the longest side. Then sine, remember our sine, it will always remain y over r. So which means sine angle t, it will always remain y over r, which is equal to p r over pt, which is equals to the value of PR is 1, the value of that one is root of 5. Then this is the answer they are looking for. You can even see already it's 1 mark. So the second part, if they are looking for cos S is on the other triangle. Cos S is on the other triangle. What we mean cos S is on the other triangle? It's on the other triangle because we are now going to put it in this triangle S R P 1 root 10 3. Then if here is 90, they are looking for this one. Then the line drawn from 90 going to that angle that is labeled, then the line becomes X. Other one becomes Y. R is obviously hypotenuse, opposite to the 90. Then cos angle S is equals to X, which is RS, divided by Y, which is what? Sorry, divided by R, which is PS, which is equals to more the same as saying that is 3 divided by root 10. And this is the answer they are looking for. Are we clear?
Yeah.
Okay. Let me take the last example of simplifying. The last example on simplifying, we are having this common example here that says that determine the value. Remember, the value is a number. It means that your answer must give you the form of a value. Question 5.2. We are here. Determine. Now, here I'm going to use the principle of reduction and also identities if possible. But if there's no way I can use identities, I'm not forced to. But as much as you can use identities, you are welcomed. As much as you can use the properties of reduction that we just learned now, you are welcomed. Now, in this manner, we are having 1 over cos into brackets 360 minus theta. It's going to be long, this one. Multiply by sin into brackets 90 minus theta. All in all minus tan squared into brackets 180 plus theta. Okay, let me switch to camera. Now let's do it generally like adults and also professionally like understanding learners. Let's see. Automatically we are given our expression in a form of reducing. Now we know 360 minus, going back to our notes, 360 minus was in quadrant number 4, and in quadrant number 4, cos is positive. So yaga odimike 1 ke ngwale simplified. So we'll have positive cos angle multiply by sine ke 90 minus. So 90 minus, remember what ke cofunction. Cofunction meaning what the sign has to change into cos. But then how? 90 minus which quadrant? The quadrant number 1. So if it's quadrant number 1, in quadrant number 1, cos and sine and tan are positive. And then cos changes, so the sine changes to become cos. Then all in all minus tan to the power of 2. And then into brackets, 180 plus theta. 180 quadrant number, 180 plus the quadrant number 3. In quadrant number 3, tan is positive. Then I will remain with positive angle. Then that is the first step working towards the understanding. Then what do we do here? Well, the thing that we do, we simplify. These are multiplying each other. They are the same. We're just gonna have them squared. So we'll have cos squared theta minus tan. Remember, our tan is a what? Tan is an identity. Since tan is an identity, we can just rewrite it in a form of sine. And remember, our exponent and angle theta. So sine is exponent theta divided by cos. Cos here on exponent theta. So you see how it works. You take it the way it is when you change it with its sign and also the other properties that goes with it. So from here, I can just simply cross multiply. And when I cross multiply, step 1 giso, step 2 giso, this is the step 3. Then step 1 says 1 multiplied by cos squared. So 1 multiplied by cos squared is going to give me cos squared angle. The sign in between is negative. Then step 2, you're cos squared multiplied by sine squared. You're valuing cos squared multiplied by sine squared. Then all in all divided by step 3, Kyo times you, which I'm going to have cos squared multiplied by cos squared. Okay, step number 3. Okay, going further, we can see that here there is cos squared, here there is cos squared. So we can wish to simplify. How do we wish to simplify? We can use to simplify by factorizing, by saying cos squared, you are our common factor on the numerator. Then we'll put it outside to 1. Then I will have 1 minus sine squared angle divided by cos squared angle multiplied by cos squared angle. Then since now the numerator they are multiplying and denominator are multiplying, I can now group the like terms and cancel them. So this one cos squared will minus, so we'll divide this other cos squared and remain with what? With 1 minus sine squared theta divided by cos squared theta. And then I learned from identity of 1 saying that cos squared theta is equals to 1 minus sine squared theta. So identity of 1 will say that sine squared theta plus cos squared theta is equals to 1. If I want cos squared theta, I will then say sine squared theta yaga kwa side ye ngwana ke shala ka eng ke shala ka 1 minus cos squared theta, which is so the sine squared theta, which is this one. So it's an identity of 1. I have just derived it from there. Then this divided by this one, answer, it gives me a new 1. This is how we arrive to the answer by just simplifying. Remember, the important part is to take it from here, knowing that cos 360 minus give fourth quadrant and cos on fourth quadrant is positive. Sine 90 minus give first quadrant, and 90 plus or minus, it's a cofunction. Whatever sign it is, it changes to cos. Whatever cos it is, it changes to sine. And then check the sign in between. Then the rest follows as we reduce. Do we have any question?
No.
A question. Is there anything you would like to ask before I dismiss?
No, not at this moment.
Okay, so which means I am declaring our lesson over. Then you will followed by the work.
You gonna give us the video of this one?
Yeah, I will upload it, I think, by tomorrow.
Okay.
If there are no questions, I'm going to send the questions just now. And then you do the magic. You answer the one that you can answer. And then I will mark you according and return you and give you the comments as soon as you submit. Thank you very much. Have a lovely evening.
Okay, thank you so much.
And good morning from our side. Bye-bye.
Bye.